afternoon, class. Thank you. You can sit down. All right, then today we'll be looking at solid trigonometry, which is the last thing we're supposed to look at in trig. Okay. The first thing we need to know about this is a plane, because we'll be looking at that. It has nothing to do with an aeroplane. Okay, a plane is any surface, like for instance the top of this table or the surface of this blackboard. Okay, so that's called a plane. Another thing too that I'd like to explain before we go into this, if there is a plane, a surface, and then there is a vertical line on the surface, and if I draw any line, okay, if I draw a line from here to any point on the surface of the table, okay, from here to here, or even from here to there, from here to here, the angle this vertical line makes with any point on the surface, with the line drawn on the surface of this is always a right angle. Okay, clear? Because if you draw that on the paper, it might not look like a right angle, but it is a right angle. Okay then. The next thing we need to know is the angle, to identify the angle between a line and a plane. Okay, for instance, this is a PQRS is a plane, it's a surface, and we have to identify the angle the line PA makes with the plane PQRS. Okay, what we do is we draw a perpendicular line, we draw a vertical line from P to the surface PQRS, or to the plane PQRS. Like I said, okay, if PQRS is the surface of this table, and the line PA is drawn something like that, what you need to do is to draw a line from this point to the surface of the table, to that plane, and then you draw a line from that point to that vertical line that you've drawn. Okay, the angle between the plane and the line is the angle between this line and the required line. Okay, so that's what I've indicated here. So you draw a vertical line, not a perpendicular line, a vertical line to the plane, and the line, and then you draw a line from that point where the line PA meets with the plane. Okay, just like that. That means the angle formed is the angle between the plane and the line PA. So theta, or angle PAL, is the angle between the line PA and the plane PQRS. Okay, is that understood? Now, next thing, we have to know the angle between two planes. Okay, for instance, we've got, let's say, the back wall and the side wall, if that was not Luvassen wall. Okay, those are two planes. Now, I've drawn two planes on the board here. One is ABCD and the other is PQCD. Okay, note here it says CD is the common line, or the line of intersection. Okay, before you identify the angle between the two planes, you must identify what is called the common line, or the line of intersection. For instance, this blackboard, if it was long all the way through to the side wall there, and that wall meet at the line. They meet at the corner. That would be the common line where the two planes meet. It would also be called the line of intersection of the blackboard and the side wall. Okay, so before you identify the angle between two planes, you must know where the line of intersection is. So this line CD is actually the line of intersection between the planes ABCD and PQCD. Clear? Okay, to identify the angle between two planes, you have to drop a perpendicular onto the common line. So since I have identified the common line, which is CD, I have to drop a perpendicular, and that line has to be in the plane, and it has to be perpendicular to the line of intersection. So what I do is I draw a line in the plane ABCD, which is perpendicular to CD, which is the common line. Then next thing it says, drop a perpendicular line onto the same point of the common line in the plane PQCD. Okay, I now have to draw a line, this time on PQCD, but it is also perpendicular to CD. And it must, okay, it must meet the line that you have drawn at a point. So I draw the perpendicular to CD. Okay, this is the line perpendicular to CD, but it is on the plane PQCD. And then we are told that the angle between these two lines that you have drawn is the angle between the planes. So this angle here, okay, if I can call it X, Y, and Z. Okay, angle XYZ is the angle between the planes PQCD and ABCD. Is it clear? Okay. Now we are going to look at some examples of just naming the angles. Okay, example 1 and example 2. In the following, name the angle between the line AB and the plane BCDF. Okay, have a look at the first diagram that I've got on the board. The line is AB. Okay, the plane is BCDF. I have to name an angle. You can create a new one, but then you can also work it out if it's already there. We have to name an angle between the line AB and the plane BCDF. Okay, if you think you know the answer, put your hand up and we'll hear it. Between the line AB and the plane BCDF. Anyone wants to have a go? Taumaku.
Angle AFD.
Angle A, he says AFD.
E.
Did you say AFD? AFE. Huh? EFD. I thought you said AFD and then, okay. EFD. Solomon, do you agree with Taumaku? Yes. Okay, they say it's this angle here, AFD. But the question says it has to be between the line AB and the plane BCDF. It will be ABC. Good. Okay, not this one, although they will probably be the same depending on the length of this one and the length of this one. It can't be this one because it specifically says between AB and the plane. Okay, note, there is a vertical line already there to the plane, BCDF. Okay, and then this will join there, therefore ABC. So angle ABC. Okay, have a look at diagram number 2. Still the same between the line AB and the plane BCDF. Let me just draw the line AB. Okay, this is the line AB. The angle has to be between that line and the plane BCDF, which is the base of the cuboid there, because we don't know whether it's a cuboid or a cube. Anyone wants to name the angle? Miriam?
Angle ABF.
Angle ABF is correct. Okay, again, there is a vertical line already from A to the base to the plane BCDF, and then from this point to there, that will be the angle that is required, angle ABF. Okay, next, the line AB okay, it's this line. We need to find the angle between the line AB and the base BCDF. Sorry, it's not the base, the plane BCDF. It's now the plane on the side. Conrelay.
Angle ABF.
Okay. Angle ABF is correct. Okay, I'll give you 3 minutes to do example number 2 before we do one example on the exercise. Okay, this time we are asked for the angle between two planes. All right, in each of the following, name the angle between plane ABCD and plane ABFG. Okay, we need to identify the common line first. So, Daniel, can you tell us what the common line is for the first diagram?
AB.
AB. Okay, so the next step is to draw a perpendicular to the common line in each of the planes. So, first of all, the plane ABCD, I have to draw. If it's already there, you don't have to draw it. Okay, I can see that BC and DA are perpendicular lines in the plane, perpendicular lines to the line AB, which is the common line, and in the plane ABCD. Okay, so if I want to, I don't have to draw one, because I can use those two. Now, in the plane ABFG, I can also see two lines that are already perpendicular to the common line. That's FB and GA. Okay, so name the angles that are not, the angle that is between the two planes. Patrick?
CBF.
Okay, C, B, F, any others? Or D, A, G. Okay, now that we've done the first one, let's see if you've got the second one correct. Name, maybe there are more than one angle. Name the angle between the planes ABFG and ABCD. Raylene, what do you think?
DGA.
DGA? Are you sure? Agnes, what do you think? You agree with Raylene? Is it DGA? Yes? Anyone thinks otherwise? Gabriel?
DAG.
DAG or CBF? Okay. We all agree that AB is the line of intersection. It's the common line. The line that is perpendicular to AB, but in the plane ABCD, or the two lines that are perpendicular, will be DA and CB. Okay, the two lines in the plane ABFG that are perpendicular to the common line are AG and BF. So the angles are actually DAG and CBF. All right, the last one. The planes are AB, C, D. That's one plane. And the other plane is ABFG. So it's the bottom plane and the plane that I've indicated. Okay, the common line is still AB. Margaret, what do you think?
Angle CBF or angle DH.
Okay, same. Angle CBF and angle DAG. Okay, now you are going to do question 1 on exercise 7 on the board. Chapter 39 in the textbook, and I think it's exercise 39.1. Nine to 11. Yeah, 9 to 11. Huh? 9 to 10. 9 to 11. Okay, letter A of question 1 says sketch the rectangle EF GH. EF is 12 centimeters and GH is 5 centimeters. Okay, you will notice in question 1, it actually gives you the steps on what you have to follow, the steps you have to follow to do the other questions that will come later on, because you will not be asked to do this step by step. Okay, now part B says calculate the diagonal FH of rectangle EFGH. Okay, the rectangle FH is equal to the square root of 12 squared plus 5 squared. That's 144 plus 25 is 169. The square root of 169 is 13. Okay, so that's diagonal FH. Then it says sketch the rectangle FH DB. Okay, FH is 13 centimeters. FB is 8 centimeters. And FB is the same as DH, which is, and BD is the same as FH. Okay, letter D, calculate the diagonal BH of rectangle FH DB. So BH is now equal to the square root of 13 squared plus 8 squared. That's 169 plus 64. 32. The square root of 232 would be, huh? Sorry, 233. What's the answer? 15 point? 15 point what? 3. To one decimal place. Okay. Number 2. Okay, I'm going to have to ask you to complete the questions for homework. There's question 2 to complete, question 3, 4, 5, 6, 7, 8, 9, and 10. Okay, 10 questions for homework. Please note, if you are using the textbook, I do not want to see any writing on the diagrams, please. If there is writing on them already, please remove it, because the pages of the books are not very thick. If you are going to keep rubbing on the textbook, it's going to finally tear. We don't have many books. Again, on this textbook, you have to do exercise 39.1, all the questions on that exercise. All right, the keyword to the pilot teacher is three-dimensional. Please stand. Good afternoon, class. Thank you.